Angle in standard position or standard angle. Try to recall the definition of directed angle. If ray OA is rotated in anti-clockwise direction about point O till it attains the position of ray OB, then the angle thus obtained due to the rotation of ray OA is called directed angle AOB, and it is denoted as shown here. The original position of ray is called the initial arm. Here, ray OA is the initial arm. The final position of the ray after rotation is called the terminal arm. Here, ray OB is the terminal arm. The point about which the ray rotates is the vertex of the angle. Here, point O is the vertex. Observe the two figures which are shown here. In the first figure, the initial arm OP rotates in the anti-clockwise direction. Ray OQ is the terminal arm, and in the second figure, the initial arm OQ rotates in the clockwise direction. Ray OP is the terminal arm. In such a case, remember that directed angle POQ is not equal to directed angle QOP. If the rotation of the initial ray is in the anti-clockwise direction, then the measure of the directed angle is positive. If the rotation of the initial ray is in clockwise direction, then the measure of the directed angle is negative. Students, note that for directed angle, we have to consider 3 points, namely the initial arm, the terminal arm, and the amount and the sense of rotation of the initial arm. Now, let us try to understand the meaning of angle in standard position. In a rectangular coordinate system, the origin O is the vertex of the angle in the standard position. In a rectangular coordinate system, a directed angle with its vertex at the origin O and the initial ray along the positive x-axis is called standard angle or angle in standard position. In the figure here, the initial arm OA of angle theta lies along the positive x-axis and the vertex is at the origin O. So theta is a standard angle or angle in standard position. Angle alpha with its initial arm along the positive x-axis, origin O as vertex, is another standard angle. For angle AOP in the figure here, you can see that the initial arm OA rotates about the point O in anti-clockwise direction to attain the position of ray OP. Here, ray OP is the terminal arm and theta is the amount of rotation. For angle AOQ, OA is the initial arm, OQ is the terminal arm, and alpha is the amount of rotation. The amount of rotation of the initial ray is the measure of the standard angle. So, the measure of angle AOP is theta, and that of angle AOQ is alpha. Now, we will learn the angle in quadrant. A directed angle in standard position is said to be in a particular quadrant if its terminal arm lies in that quadrant. We will try to understand this definition of angle in quadrant with the help of the figure. In the figure here, the terminal arm OP1 lies in the first quadrant. Therefore, we say that angle AOP1 is in the first quadrant. The measure of angle AOP1 lies between 0 degree and 90 degree, or it lies between minus 270 degree and minus 360 degree. In this figure, the terminal arm OP2 lies in the second quadrant. Therefore, angle AOP2 lies in the second quadrant. The measure of this angle AOP2 lies between 90 degree and 180 degree, or it lies between minus 270 degree and minus 180 degree. In this figure, the terminal arm of angle AOP3, that is, arm OP3, lies in the third quadrant. Therefore, angle AOP3 lies in the third quadrant. The measure of angle AOP3 lies between 180 degree and 270 degree, or between minus 180 degree and minus 90 degree. In the figure here, the terminal arm OP4 of angle AOP4 lies in the fourth quadrant, and hence the angle AOP4 lies in the fourth quadrant. Its measure lies between 270 degree and 360 degree, or it lies between minus 90 degree and 0 degree. Let us do an activity here. One example is given, and we have to find the answer for the question put in it. Example: for the angle in standard position, if the initial arm rotates 220 degree in anti-clockwise direction, then the terminal arm is in which quadrant? Here is the solution. Since the initial arm rotates 220 degree in anti-clockwise direction, the measure of that angle is 220 degree. If the measure of angle lies between 180 degree and 270 degree, the angle lies in the third quadrant. So, the answer is the terminal arm of the given angle lies in the third quadrant. Example 2. For the angle in standard position, if the initial arm rotates 25 degree in clockwise direction, then the terminal arm is in which quadrant? Solution. The initial arm rotates 25 degree in clockwise direction. Therefore, the measure of that angle is minus 25 degree. Therefore, the given angle lies in the fourth quadrant. So the answer, the terminal arm lies in the fourth quadrant. Example. For the angle in standard position, the initial arm rotates 305 degree in anti-clockwise direction. Then the terminal arm is in which quadrant? Solution. The initial arm rotates 305 degree in anti-clockwise direction. Therefore, the measure of that angle is 305 degree. Since the measure of the angle lies between 270 degree and 360 degree, the angle lies in the fourth quadrant. Therefore, the terminal arm lies in the fourth quadrant. Example. The terminal arm is in the second quadrant. What are the possible angles? Solution. Here, the initial arm can rotate either in the anti-clockwise direction or in the clockwise direction. If it rotates in the anti-clockwise direction and the terminal arm lies in the second quadrant, then the measure of angle will be between 90 degree and 180 degree. And if it rotates in the clockwise direction and the terminal arm lies in the second quadrant, then the measure of the angle lies between minus 270 degree and minus 180 degree. With the examples we have studied, now we know to determine the position of any angle in the quadrants. What if the terminal arm of a given angle lies along the axis? We are going to consider the angles whose terminal arms lie along the coordinate axis. So, a directed angle whose terminal arm lies along the coordinate axis is called a quadrantal angle. In the figure here, angle POQ, angle POR, angle POS and angle POP are quadrantal angles, as the terminal arms OQ, OR, OS and OP lie along coordinate axis, that is, positive side of y-axis and negative x and y-axis. Have you noticed an interesting fact here? Quadrantal angles are always an integral multiple of 90 degrees. Let us see one example. Example: the terminal arm of an angle is on negative y-axis. What are the possible angles? What can you say about this angle? Here, the terminal arm lies on negative y-axis. If the rotation is in the anti-clockwise direction, then the measure of the angle is 270 degrees. And if the rotation is in the clockwise direction, then the angle is minus 90 degrees. So, the possible angles 270 degrees and minus 90 degrees. And as the terminal arm is on the y-axis, they are quadrantal angles.